Hi, and welcome to BTS Podcast. I am your host, Lene Cook, and I am so excited to have Peter Neff on the podcast. He and I met through a NASA social event, as we will say during the interview, but I do just want to give a quick shout out to NASA Social. I had such an incredible time at the ICESat-2 launch, and I was just insanely impressed by the variety of people that were there and how friendly everybody was. It was a really, really good time. You can look into going to a NASA launch, literally just search NASA Social and you will find where to and how to apply. Please don't be intimidated. Just share how you want to share NASA content, and they'll either approve you or they won't, but it is worth a shot. A lot of people flew from all around the country to go to the ICESat-2 launch in Lompoc, California. Peter and I met there. It turns out that we both live in Seattle, so I met him at the UW campus and got a chance to check out just what he does. It was really, really incredible. I am so happy to be able to just share this information with everybody. Peter is currently in Antarctica, and you can find him at Peter_Neff on Twitter. His Twitter is in the description of this podcast. Music on this podcast is by Benjamin Betherum. Look up Benjamin on SoundCloud. The work he does is really awesome. It's soundcloud.com/Betherum, Bethurum. I may or may not be pronouncing his name wrong. He sent me a recording with how to pronounce it, and still, I feel like I'm doing it wrong. Anyways, thanks, Ben. I'm so stoked to have your music on here, and I hope everyone enjoys this interview. So I am here on the UW campus with Peter Neff, and you are a glaciologist.
Yeah.
That's okay?
Yeah, that's fair. Okay. I was always trying to figure out the way to most accurately summarize interest, but there are many flavors of glaciologists, but I'm one flavor.
Okay. And Peter and I met thanks to NASA's NASA Social program, which is super cool, and anybody with a social media presence at all, whether that means just your friends on Facebook or whatever that, or if you're into Reddit or whatever that may be, you can literally just go online and apply to go to a NASA launch, and it's pretty incredible. So that's how Peter and I met in Lompoc a few months ago, I think.
I think it was just a month ago.
Was it?
It feels like a long time ago.
It feels like a very long time ago.
Yeah. It feels like the world is moving slowly and fast at the same time.
Because it is, for sure.
Yeah.
At the ICESat-2 launch, which was really cool, and I imagine super relevant to your work.
Yeah, but also just super cool as a human experience as well. But
yeah.
Like the thing with NASA is like there's sort of this underlying fan base where anybody who grows up in the U.S. basically and beyond is a huge fan of NASA just because they do this like fundamentally radical exploration. So
yeah, and I like that it really does run the gamut from just like person who thinks that astronauts are cool, which they are, and that's great, to like conspiracy theorists,
yes.
Which is like a real treat.
Oh yes. Yeah, it was an interesting, the NASA Social mix of people was super interesting. I had no idea what to expect.
Neither. I was really nervous, to be honest with you, that like maybe I wasn't smart enough or cool enough or like whatever, and then it was just such an incredible mix of like people from all over, from all different backgrounds.
Yeah.
Yeah, it was very cool.
It's a smart way for NASA to keep the fan base going and get tons of different exposure, so.
Totally.
Yeah.
And so I guess let's backtrack a little bit and talk about your work, because the podcast, I know I briefly explained it to you. Mm-hmm. It's called BTS, so Behind the Scenes, and we are all about looking at the behind the scenes of like a final product, whatever that may mean, really kind of with the goal of making some career paths and industries seem more approachable to people, and humanizing the people behind the final products that we see, and also to have an impact on consumer choices, so that people are making educated choices when it comes to what products they're buying. So there's like a wide array of people on here from all different backgrounds, and I think you're in fact the first like scientist we're having on, which is exciting.
Breaking down barriers.
Yeah, I'm gonna try and talk my semi-shy aunt into being on, and she works, I don't know if you're familiar with the Jackson Laboratories, but she does like bioinformatics there. So
okay. There are too many labs. I'm not
very
familiar with
different
that one,
sides of
but-
science, but it'll be cool. So, do you want to share a little bit of your background, like what programs you've gone through? Because you do have your Ph.D., if I'm not mistaken.
Yep.
So, Dr. Peter Neff.
Correct.
Awesome.
Rock doctor, ice doctor.
Do you want to walk us through some of that?
Sure. Yeah, so I have my PhD in geology, and I have master's and bachelor's degrees in geology as well. So Bachelor of Science and Master's from right here at UW, the Earth and Space Sciences Department, which we're in right now. So it's where I discovered geology, and that really was my entryway into more of the, I guess I sort of do climate science now through studying ice. But the beginning thread was, I think, coming to school interested in history, but also sort of having a quantitative background. I'd done science events, Science Olympiad in high school. So it was really the history and the stories behind geology that attracted me. You know, you can sort of go out into a landscape, and based on basic observations of what you see and the structure of the hills and valleys around you, you can start to learn about what caused those things to be there. So there's this sort of extra dimension that knowing about geology adds to being in the world, and that's sort of, I guess it was sort of life-changing to realize that. And so I got super excited about geology and signed up as a major my first year, and then got really lucky and got a job in this lab. And from there, it sort of just continued in sort of enthusiasm. Like, I was just really passionate about learning more about this stuff, and the fact that I got a chance to get my hands dirty at an early age, and early in my career, I just sort of, I guess, you never stop pushing. Once you find something that you like, it is challenging to stay in this career. It's not a super straightforward career path.
Right.
But what we get to do is pretty dang rewarding and unique and bizarre sometimes in many ways. But yeah, so geology is the educational pathway that I came in through, which involves a mix of the hard sciences of physics, math, chemistry, but just enough of all of those that it kept my attention through those sort of difficult first years of studying at university. And then, now I'm constantly applying different aspects of all of those to studying polar ice almost exclusively now. It's what I work with, and pretty much just Antarctic ice. So I call myself a glaciologist because ice is the common thread through everything that I do, but I'm interested in ice for what it tells us about the climate. So for what every layer of snow and ice that never melts in a place like Antarctica, that's a little package of information from that year, and they just stack up.
Right.
So that's what I work with.
Which is super fascinating to me, because I guess I'd thought about that in some ways through ice, but when I was a kid I was obsessed with all of the insects and bugs that get trapped in the sap and stuff of tree. I can't remember the name for it right now.
Yeah,
of amber. Yeah, and that was my favorite thing as a kid, and all I wanted was my parents would get me them for my birthday and stuff.
Nice.
And it was the one thing I wanted when we went to Denmark, was that I saw one of them, a bug in the amber, and I was like, that's the only thing I care about when I was 7.
Nice.
But
yeah, that's basically what the ice does to everything that ends up in the atmosphere. If it gets attached to a little snowflake and falls over Antarctica, it's preserved, and that's what we work with.
So then, are you also able to, and this is totally sidebarring because my original next question was going to be about talking about career paths, so we'll get to that in a second, but now that you're saying that, I'm thinking through how, all around the world, obviously we're freezing ice in our freezers, and we're freezing, bars are freezing, and so, are you able to look at that kind of ice and know what kind of toxins exist in a region based on, the ice you get from, in, a whiskey?
You certainly could, yeah. I mean, I would imagine there are people who trace contaminants and stuff like that through. I mean, I don't think you necessarily need a frozen sample in that case. We can test tap water for, what we do in this lab is it's a stable isotope lab, so we measure the different masses of an atom So in the case of water, hydrogen or oxygen, there are a couple of stable forms of those elements, and because they have different masses, they move through the hydrologic system in a particular way based on those things, and so we can tease out a bunch of different processes from the temperature when that rain or snow falls. We can get that sort of information from stable isotopes. So you could do that in tap water, and you do. So you'd see tap water here in Seattle, because we're relatively close to the ocean, would be pretty close to an oceanic value. Whereas if you measured the same in Colorado, where the water has traveled a long way and it's been distilled through that process, it'd have a more extreme isotopic value. It would be depleted of heavy isotopes, and so that's the sort of technique that we use. So that's how we know the temperature in the past from ice cores. We look at the isotopes in those water molecules that are ice. So
that's super cool. So that question mainly came from I was thinking through using what you do, but to compare it to what is in the air from 5 years ago, right? So if you have that sample, being able to just do that in that straightforward way, that's a little bit, it's more measurable in a immediate format than pulling old data that formats may change over the course of 5 years, I imagine.
Yeah.
So that's where that came from. It was just on my mind. So
No,
at any rate,
that's essentially where we can't measure what the tap water was like 10 years ago, so we have to go to some place where that water is
unless
archived.
you have old ice.
Yeah, right. Somebody's got a big freezer.
Right.
Like we do. But otherwise, you would go to a glacier where the ice hasn't melted, and then you can get back to that. So
Very cool.
We'll measure lead concentrations in the ice, and we can very clearly see where ice from the 1970s is, because it has massively more lead than we have in the atmosphere now.
Right.
And that was actually partly sort of circular. They saw this in Greenland ice cores, that lead values were rising into the 1970s, and it was largely due to the lead they were putting in gasoline to lubricate engines.
Oh,
and so
interesting.
that was partly phased out after seeing data from Greenland, where we had this big spike in lead in the 1970s.
That's incredible.
And now we use that as a marker, an age marker in the ice. So if we see that spike in lead, we know we're back to the 1970s, and then
and more than just one way.
Yeah.
So okay, so then let's talk about career paths a little bit, because I'm really interested in from your bachelor's and master's, and then obviously with your PhD you have to get more specific.
Yeah.
And then even after that, what kind of career paths were available and are available to you right now?
Yep. Yeah, so I would broadly consider myself a part of the field of geoscience. So I wouldn't call it, I do strictly geology anymore. Geoscience is sort of the modern application of these massive data sets that we now have observing the planet, and using those to more quantitatively understand how the Earth operates. And that's what we're all sort of after, our individual little piece of understanding how the Earth works. So geoscience is interesting because people come into it from a huge range of backgrounds, from biology, so biogeoscience, geobiology, to physics, chemistry, math. So people often will end up all the way to their PhD never having studied anything in geology or geoscience, but they have a background in computation or physics or pure chemistry, and then they apply it to a geological an Earth-focused question. And so we have a really broad entryway into geoscience. And for me, I feel like one of the things that our community doesn't do very well is provide a breadth in what that future career path can be. So I guess maybe I got into applied research pretty early, but I always felt through my PhD as well that the only mark of success is if you stay in academia and you become a professor and you do your research forever, and that's highly valued, even though the impact of it is questionable.
Well, and that was my next thing is and that's what's so wild to me, because a lot of my family on one side of my family is in that world where they've stayed mostly in research or academics, which is incredibly valuable in some ways, and in other, like as a marketing person, as you can imagine,
soul crushing.
Right, where I'm like, but how do you get that into the world and make it like clear and concise to people and digestible? And they're like, well, the facts should speak for themselves. And I'm like, no one's reading the facts.
That's right. Yeah, like, who ends up with them? Right,
and like, and it's so interesting and so difficult because in two ways, from my point of view, is one, getting that information out there. Like I was listening to this, I think it was, I can't remember which podcast it was. It was something about innovations, and it's from like a different network than what I usually listen to. Mm-hmm. And I did not realize that like, that I think it was like Gregor Mendel's like P research was basically ignored until some other person was doing research and dusted off this old paper and was like, oh, this can apply to so much more. And then I think started applying it to like fruit flies or something. Yeah. And I was like, I already am personally overwhelmed when I go home and my grandfather collected books, and they're all in order of like chronological order. So from like the Epic of Gilgamesh up until he passed away in like 2002. Okay. And so like I was in the room of like Joan Didion and Joyce Carol Oates and like that era. Mm-hmm. But already when I go home, I'm like, oh, I should just quit my job and stay here and read all day. But then there's so much more like good information that's coming out right now. And so when I think about like all of the research everyone's doing, even if you were to pare it down from just stuff happening in 2018 and then just the stuff that's like peer reviewed and like as close to reality and truth as possible, like culminating all of that into an actionable way that gets people operating on the same foundational kind of like, you know, and I'm putting quotes around this for listeners, facts, like, that's insane, right? And like, and the stuff that does bubble up, what a nightmare, because I'm sure a lot of people who are listening know this already, but like a lot of the stuff that bubbles up as maybe it's countering a previously like widely accepted theory, those fixes those don't even get bubbled up in like applied medicine. So like they're certainly not getting bubble up when it comes to like changes in the world around us. And so what do you do, like what is it that you've done on your end to like get that out? Because I've seen that you've collaborated or worked with like an artist before, I think, which was super cool to see, because that is certainly a dream of mine, is for someone to be like, hey, we really like your photography and video style, like why don't you just come into the world with us for a while and like capture it? Like that's the dream. Which I think is a natural, to me, science and art is like a natural avenue. Absolutely. But outside of that, like that's probably still going to attract a pretty strong crossover audience. Like outside of that, like what do you do to get your findings outside of academia?
Yeah, I think most people don't do much, and I don't know what the assumed pathway is besides the students that you teach, right? I mean, if you do become a professor, the bulk of your job 9 months of the year is to teach, undergraduates at most institutions. But it's another problem that we have where the end of our scientific process is publishing a peer-reviewed paper that we fully know. To
other academics, most likely.
Yeah, basically, because most of it's behind a paywall as well, and especially the most highly sought-after journals, Nature and Science are peak journals as far as viewership, which really the only thing that academics care about is how often their papers are cited, which is a purely academic thing. There's sort of this vacuum between putting our paper out there and it actually getting taken up by anybody, and the people that operate in that empty space are science journalists, and it's a space that's become more important, particularly for us in climate science, because obviously we have information that really needs to be acted upon.
You're a little under fire right now.
We're under fire
in many ways.
I wish we should.
From all directions.
There's no good reason that it should be under fire as a discipline, but So one way that it's described is we have this loading dock style of delivering our results, and we put them out there on the loading dock, but somebody has to come and find them to then proceed and do anything with it. So
It's a scavenger hunt that only the person planning it knows about.
Yeah. So, we do have some really important organizations that manage to do that space. So, and it's on my mind often because my wife, Heidi Roop, is a scientist at the Climate Impacts Group here. So she is also a PhD researcher. We did our PhDs together on paleoclimate, past climate. But she's
cool.
Now, got tired of publishing in the Journal of Paleolimnology.
Right.
And wanted
I'm sure has a very widespread readership.
Super widespread, yeah. A few people everywhere. But so she now takes information, from big international bodies like the Intergovernmental Panel on Climate Change that summarizes the state of our research every few years, regionalizes it, and then delivers it, builds those relationships so that, not only are they spewing information at local tribes or city governments or the state government, they're building a relationship to figure out what those people want and need and actually getting that. So it's, it's not a one-directional process, which back to academia, we traditionally do with this sort of one way, like, let me lecture at you for 1 hour, students. That's going to be, it's my assumed way that you're going to receive information and it's actually going to be useful to you. But I think the more that us younger people who have been around the amount of information that we have today, I think that as we all ascend into positions where we're teaching and we're interacting with the public, there's a greater expectation that you actually think about how you're doing it.
Which there should be.
Yeah.
That's like, and I think on top of it, we all have social media, right? Like if you look at people 20 years ago, those journals were really outside of having a good PR department that's then like knocking on the doors of the New Yorker and like whoever else might care. Those journals were like the main way of getting out to the world, and then hopefully it, like goes into other things, right? Like it hopefully then gets cited by one person, and then that gets cited by more publications.
Yeah.
But in today's world with, YouTube, Twitter, everything that we all have as options, I think that you're right, that like this generation is more in touch with those tools and more comfortable, because there for a long time has been a lot of hesitation, and I imagine it's like this in like very specific science publications, is that there's like, well, then how will we make money if there's no paywall?
Yes.
And it's like
a huge discussion.
Yeah, but you're not going to thrive with like your dwindling viewership and subscribers.
Yeah.
And if they were to shift to a more like media model, there'd probably be, and then that also opens them up to other journalists who want to cite their work.
Yeah.
Granted, that then also opens you up to a lot of incorrect citations.
Absolutely,
I imagine, because and spinning of content, just potentially not even intentionally, just based on lack of familiarity with the space.
Yeah. Andy needs to come in.
Please hold.
No worries.
Hi.
Time to go home? You don't have to do it silently.
You're fine. We can keep talking. That's really interesting. And so then what is your exact job here?
What is my exact job here? I'm a postdoctoral research associate here, so I finished my doctorate now 3 years ago, and I have support here half through a project that we presented to the National Science Foundation, and it was selected to be funded. So that's a project that's actually taking me to Antarctica on Sunday.
Right, which is why we were in a bit of a time crunch to get this, which is good, because I feel like if we weren't in a time crunch, it would have been like, oh yeah, sure, maybe next week.
Yeah, it's always hard.
So then to back up a little bit from that, for people who aren't super familiar with like these types of programs, can you explain a little bit the process of how you get that funding, how you know where to apply, and like what kind of work to do, and then had you not got funding, would you just not get paid? Like, how does that work?
That's a pretty much a direct yes. Yeah, if you don't have funding, you don't get paid. This at my career stage, postdoctoral, it's sort of it's a 0 to 5 year career phase where you are essentially getting a little extra mentorship on the additional managerial aspects of being in academia.
Bye, Andy. Nice meeting you.
Yeah. So I'm fully independently doing research, still in close consultation with a faculty supervisor. Often you're just you're purely doing a project of theirs. Because you have to come into a project that's already funded.
Right. That is strategic.
Yeah. So there's this rolling, structure of as you're finishing your PhD, you're trying to find a postdoc, or you can apply directly to try to get a faculty position, which is more common in some research areas. So yeah, it's an interesting career phase where you're trying to publish as much as you can, start doing original work and establish your own research trajectory, and get grants funded. And essentially part of your job is to get a full-time job. So your supervisor, the ultimate mark of success for your supervisor would be to say, oh yeah, my postdoc, now is a professor at, name your prestigious university.
And is that the full-time job available to you after that as being a professor? Like, what other full-time jobs are, would you look at and go oh, this is a perfect fit? I think if you weren't really wanting to go in academia, my sense is that it would be silly to do a postdoc, because it's just a way for in the pyramid structure of how research is done. I don't think people who set up academics would want it called a pyramid structure.
Oh well, I think they all know. But there's a base layer of undergraduates and then graduate students.
It's true.
That do graduate students do the research. At least in my experience, they are the ones. You don't have your PhD yet, but after you're a couple of years into your PhD program, you are a pretty experienced scientist in a lot of ways, and you're the grunt doing the work. And then a postdoc is just this awkward continuation of that. You're in this gray zone purgatory between being a student and being a faculty member. So officially I'm classified as faculty, but I'm not a part of departmental decisions. You're not sort of fully brought into the fold.
Interesting.
And it's a great, it has upsides because you sort of have more independence. You have less of those extra service items nagging at you.
Administrative type stuff, I imagine.
Yeah. So it is nice, and it definitely gives you space to sort of come up with that idea of what distinguishes your research and what little niche you can fit into.
Interesting.
Question you can chase after. So yeah, and we're cheaper than grad students too. So even though they pay us a more livable wage, we don't have tuition costs.
Oh, that's true. Yeah, that is a fair assessment. So then what do you do on a day-to-day basis?
I mean everybody's research process is different. So right now I don't have a lot of lab work. We've been gearing up for a field project for quite a while. So the first 2 years of my postdoc I did at the University of Rochester, where we were designing, building, and testing a piece of equipment that we have to take to Antarctica to move
this
towards,
weekend.
Yeah, we head down this weekend, and I'll be there for 3.5 months.
And so when did you start working on that?
That project started. I mean, I signed up for it before my PhD was over. Right, I got a postdoc lined up.
Right.
So we started. We've been discussing this project since early 2015.
Wow.
And we applied for funding in the first half of 2016. It took about 2 years for that to be the logistics to be hashed out and the funding granted. So it's an international Antarctic science project. So we have partners in Australia because we need to go to the part of Antarctica that they operate in. So we had to get co-funded with the National Science Foundation in the U.S. and the Australian Antarctic Program. And as you can imagine, two government bodies negotiating across
what a treat.
an ocean. Yeah. It took a
so
while.
That's why it took so long.
Yeah, and the logistics of Antarctica being what they are, we're a pretty big project, and so we ended up getting delayed by a full summer research season because the Australian program just wasn't ready to. We just sort of, it wasn't our turn in line at that stage.
Oh, interesting.
And so we got bumped, which was quite difficult for me, and that was part of what ended up getting me over here to UW in Seattle. there's a lot more to it as well, because my wife is also an academic, so we're constantly both trying to navigate the field and get jobs in the same place.
Right.
Yada yada yada.
That's which I imagine like that's hard enough on your own.
Mm-hmm.
But then when you're like trying to make sure that you're applying in the right, like that you're each applying to similar locations, and then you hopefully also get called back in the same location and not different ones.
Yeah.
That's a lot of logistics.
Yeah, it's a lot of leapfrogging and figuring out who's going to take the lead for now, and just piecing it together. I mean, it's not, plenty of couples do it all over in every different career, but yeah, there are just very few. Like when you're doing something that's so specific.
Yeah.
I fully realize that my Antarctic science research, if I stop doing it, nobody's going to die. But at the same time, I feel like I'm pursuing a worthwhile enough question that I do have a decent chance of attracting a university to.
Right.
To
and so what is your
position.
question?
My question is, can we better understand the part of Antarctica that's changing the fastest? So if we, from here you go straight south in the Pacific Ocean, you'll hit the part of Antarctica that's where the glaciers are changing really fast, and they're a big reservoir of ice that is going to contribute to sea level rise, because we are living in a warming world. That's the progression, and we're trying to figure out the pace at which that sea level rise is going to come, particularly from that spot, just because it's a big reservoir of ice, and we don't quite know how fast it's going to behave. Mm-hmm. It's in a quite difficult part of Antarctica to get to. It's the furthest from any research base. It's right between where the U.S. traditionally operates and the United Kingdom. So we're starting to work together. So my research is really just trying to push the glaciology research community and our ice core research community, push us from the inland of that part of Antarctica towards the coast, where we know the ocean is what is causing these glaciers to flow out and into the ocean faster. There's warm water that's getting underneath floating ice, and we can get climate records from right there where that's happening, but we don't have them just because nobody said we need to go get these. So I'm that guy. So
say there were a best case scenario where the world was based off of like actual logic.
Oh yeah.
And you were to come back with the research and go like, okay, these factors are causing the damage, and that were to be shared with like the governments in question, or I suppose like in control of that area, which is insane to me because I'm also like water moves.
Yeah.
And so like really everybody is responsible because it's not like it doesn't stay in one place. So like everything makes an impact, whether it's small or large or whatever, but like cumulatively we are all responsible. It is not up to like whatever like one country to then be the one that makes the right choices and saves everybody else.
Sure.
Really?
Maybe we'll come to that. Yeah.
Right. But it's just a little wild to me that like, I mean, that we think of our environment as separate from us anyways, because like we're a part of it. Like it is not this like separate entity that you then step into. Like there are worms like under our feet, under the cement. Like it's still there.
Right.
And it's like a bit of like a game of hot potato where people are like, well, this isn't really our fault. When it's everybody's fault. So in a best case scenario, that information gets gathered. You get like some tangible like X, Y, and Z need to stop. Then what would happen? Like in a fantasy land, all red tape aside.
What we're doing is more like we're trying to understand how quickly a single glacier, a massive glacier, something like 50 miles wide, like really big features, how quickly they can behave. So the question that we're asking is how much sea level rise from Antarctica, how fast? And we're trying to understand its past behavior to be able to say with more precision what 21st century sea level rise is going to be. So essentially what we want to do is just narrow the uncertainty and give a clearer answer. We say, look, this is the likely range of sea level rise. So we're not after it sort of stopping anything at this point. So in climate science speak, we'd call it mitigation. we don't have ways from the Antarctic side of things to mitigate what's going on, to slow down melt, things like that. We basically just want to provide the best guess of what to plan for sea level rise. So it's the information that coastal planners, that city planners need. So if you're people that are going to build seawalls or other structures to protect New York City, how big do they have to be? And so our uncertainty, I mean, it's sort of 21st century sea level rise is going to be something between 1 foot and 3 feet, most likely. But we can never rule out that Antarctica is going to totally surprise us and behave much more quickly than we think it should. So it's all, there are a lot of things that we're trying to pin down. But
so then how do city planners get that information?
Right now, splashy papers that come out in Nature actually sort of get transmitted. And so at this point there are a couple of models for how Antarctica is going to proceed, and my phone's going to blow up. But they're essentially like toy models that people are playing with. I don't mean like climate models and models of ice sheets are incredibly sophisticated, but they're still not an accurate representation of nature, of how the Earth actually operates. So a model that gives really interesting information, but we know has big problems, that is out there. And like I know that coastal planners in the Netherlands have looked at it, and we're like, I mean, it gives them information to act on, and in this case, it's probably the projection from that paper that I'm thinking of is more probably exaggerated on the high end. So what they build would be over engineered, which is great safety wise, but if you're looking at the pure economics of it, you don't want to be spending any more than you should to protect your
if it's overkill,
your coast. Yeah, you want to be building something that's fit for purpose, right?
So then how many other people do you say, or do you know, like, do what you do in the world?
I mean, the core community of people that I interact with would be a couple hundred.
Okay.
We have larger organizations, like our biggest society in geoscience is the American Geophysical Union. So overall, from space physics to glaciology, it's like 25,000 people, or the membership is probably even larger, but the annual meeting is that big. We have a cryosphere section of that's like on the order of 1,500 people.
Okay.
So that's the sort of size of the community that studies ice, from climate records that we can pull from the ice to modeling the numerical, the physics behind how ice flows. So.
And so then within that, I imagine that there should be information sharing across, like, here's your and I imagine obviously other people are also studying Antarctica, just potentially different areas than what you're looking at, it sounds like. And so then how do you all come together? Is that something that that the teams do, is go like, okay, instead of, Peter and his team putting out this paper and us putting out this paper, that we can kind of combine forces and put out a more succinct or digestible and like aligned point of view together. Does that happen? Yeah,
and that's there's a mix of the importance of all those different parts to how we communicate in academia. So peer-reviewed published papers are the slower, the slowest form of communication, but it has that higher level of having been peer-reviewed. So it's the bugs are worked out a little bit more. But we have to go to conferences and workshops a couple times a year to sort of on that earlier end of, we don't know exactly what the result is here, but we've got some interesting information that this group needs to see, and together we can make sense of it. So small workshops, 20 people to 100 people, a couple of those per year would be pretty common. And then we have our big annual meeting. At least in my community, it's pretty common that every year you would go to this American Geophysical Union, and it's just this massive reunion of all the people you've ever worked with before. So we rely on that, and there's really a lot to be said for, like, I'm thinking of, we travel to a lot of these workshops, and we fly a lot, which is counterproductive as far as carbon emissions.
Right.
But there's that human element of science, where it's a bunch of humans trying to understand the planet, and if we don't have personal relationships with each other, there's a loss of transmission. Basically,
right.
like my closest collaborations are my closest friends, really, and it's just maybe that this gets across a little bit of how deep into this stuff we get, where it's like it's my life. It's a massive fraction of my life is thinking about this stuff, and not doing a few of the other things that somebody that's less obsessed would do. I think about Antarctica every single day. Like it's a weird thing to do, but it's just, I hate to use the word snowball, but once
oh God,
yeah,
understandably so.
Yeah, once you get going, and there have been plenty of times where I consider whether or not I really should stay in academia for all that it requires of me, and for how my skills do and don't fit into the mold. But if I've been doing this for 10 years now, I have this sort of level of understanding and expertise that would be lost if I fall out of it. So there's that sort of pressure to sort of keep applying your skills.
And I know what you said with the postdoc doctorate program you're in right now, you have like a mentor basically. Have you always had mentors to kind of like lead you in this direction? Did you have to ask for those? Like, how did you kind of get that leadership from somebody and advice from somebody in which direction to go?
Yeah, I got really lucky and had a great mentor from the first opportunity that I had right here in this lab. So my supervisor, Eric Steig here, quickly became my biggest mentor when I was undergrad, and then we have been friends ever since. And it's that friend, mentor, colleague relationship now where he's my biggest supporter, and also somebody who challenges me, and we feed off each other and find cool new ideas, and yeah, from that initial mentor, it's sort of getting advice, and when you're looking at the next position to go to, finding a Ph.D. program, and you try to consider somebody, a project, but also a person and an institution that are going to be productive, right?
Right.
Don't just go for the big institutional name that you're after for prestige. You're working on a project with a group of humans in a place.
Right.
And so all of those things matter. The experience is always going to be a mix of good and bad. There's no perfect place for you. So yeah, I've had a really interesting jump through from the first big question for me in my career was, do I stay at my home department to do a master's degree, or do I carry on and go get another experience at another school? And I had a lot of back and forth with people about how productive or unproductive it is to have 2 degrees from one university. And in my case, it worked out totally fine. I had a great project to work on here for my master's, and it really helped me be ready for my PhD. So I went to New Zealand to do my PhD at Victoria University of Wellington to work on a project, an Antarctic ice core project with a particular person. I had everything lined up as far as what you need for that program. But PhD, so I guess what I was thinking of, a PhD in New Zealand is in the European model, where you spend 3 years just doing research, whereas here in the U.S., for your first 2 years are largely coursework. That's very specific applied coursework, and then you have 3 to even 4 years of pure research after that. So the time frame is different. The level of, the amount of time you get to really dig into that topic is quite different between the two. And so I was better prepared for my PhD for having done a master's beforehand. So you could also go straight from a bachelor's degree to a PhD.
Oh, interesting.
But there's a lot more development that needs to happen in between.
Yeah.
It's just, you never know that the next decision is going to be the right one either.
Right. As with anything.
With anything, yeah. And a problem that I definitely have is when I decide to go do something. I don't know that I've gotten into a situation where I felt like I had to get out of it, or that I couldn't see it through. So I have this sort of stubbornness where I'm afraid of that failure, so I just sort of push through, even though it's sometimes not ideal.
You may not want to dig into like the sunken cost materials that are out there, because it's I listen to two of my favorite podcasts are I think his name is Russ Roberts. He has a podcast called Econ Talk. I've
not heard of it though.
It's been going on for years. My dad showed it to me probably like 8 or 9 years ago, and then my other is Freakonomics, and they both Freakonomics in particular has a recent episode about like the importance of knowing when to quit.
Yeah.
And that's so interesting, because I am somebody who's always just powered through stuff no matter what, and only in recent years have I found that there's been some projects I'm on that I'm like, oh, actually, this isn't contributing to anything in my life except for being a time suck.
Yeah.
I have a choice in this. I can just stop.
Yep.
And it's a valuable lesson, but I mean, as long as you make those, as long as you're in things that you're excited about. So then, speaking of which, what do you think is like the next thing after this? Because I imagine after this trip, which it sounds like is a fairly lengthy trip.
Yeah, very long.
How long?
3.5 months. So,
3.5 months.
Yeah, I leave November 4th, and I won't be back from Antarctica until Valentine's Day.
Oh.
So mid-February.
Wow.
Yeah.
And so then you'll presumably have a lot of research to go through and a lot of findings to go through. When does this project end, and then like what's next, and like what does that time frame and planning look like for you?
Yeah. So the majority of the work for this project will take me through the end of 2019, the end of next year. So in that time, there's a lot of pressure to line up the next thing. So our the season for applying for faculty jobs at universities tends to be the fall and into the winter. So after faculty members are back from their summer research and all of that, they put out advertisements for jobs. So so that is the biggest thing for me. I do want to get a faculty position because I like the balance of, or in my mind, I envision that the balance between teaching and doing research is what I like. I really like teaching and getting our information out, and not only formal teaching, but getting out into that vacuum of space between where our results are presented and their actual uptake. So in the midst of preparing for this field season, I'm putting out applications and interviewing for jobs, and part of the trouble with the Antarctic field work is that I'm now gone for 3 months of the application and interviewing season.
Right.
So I don't know how that's going to impact me, but it's not going to be the best.
Yeah.
Yeah. So I'm trying to get a bunch of applications out the door before I leave.
Before Sunday.
Yeah, I mean, we have a bit more.
Well, thank you for taking this time out of your schedule, because that is insane.
I mean, I don't want to be filling out these applications, so.
Well, in that case, you're welcome.
Yeah, it's procrastination.
Exactly, productive procrastination.
Yeah, that's right. That's a really good way to put it. So I'll keep doing all of this stuff, and we have some connectivity when we're in Antarctica.
Yeah, I was going to ask, do you have Wi-Fi? Can you tweet? How will we follow along?
Yeah, so while I'm on the main research station, I can tweet, and I'll be giving updates that as much as I can. And then when we go to our field site, we're down to very limited email, no
Instagram stories.
It's like 1996.
Okay.
We're talking here.
Text only.
Satellite email.
Make a sandwich while it sends.
Yeah, for sure. Yeah, and that one family member that tries to send a photo is going to clog it up for everybody.
Right.
Everybody's going to be angry at you. So, yeah, we'll have 2 months where I'm out. We'll be 100 miles or something from the main station, so it'll be 10 of us dropping down to 7 of us for 2.5 months out, essentially just camping style.
Oh God.
Yeah, it's a long one.
That's so cold.
So I'll be passing thumb drives back to the station where they can then upload information to the Antarctic program, and they'll be sort of tweeting at me.
Interesting.
Updates.
And what is that program's Twitter handle?
I think it's at AUS Antarctic, AUS, Australian Antarctic Division.
No underscores?
I don't think so.
Okay, interesting. And then your Twitter is?
At Peter_Neff.
Okay.
Yeah, so,
Twitter. Neff is spelled like the brand that we all had the socks of in high school.
I wish I had thought of that. It's so weird. I never would have thought of using my last name like that. But
yeah, well, it's missed opportunity, my friend.
Hey,
Ice it is instead.
Yeah. Yep. All the glory.
So if there was one kind of big kind of overarching take, because you did mention, and this is on my mind too with as much as I travel, is like the impact that taking flights has on the environment. But if there was like one kind of, three. If you could choose a few kind of high-level things that people could keep in mind for the way that they make decisions that can have a either positive or neutral impact on the environment that a lot of people don't know, like what are some of those things that you would say to, the world?
I mean, I think even if more people start to consider the impact of their actions, so the emissions and the greenhouse gases that come from driving, flying,
or purchasing a new car, right?
Yeah.
Or like what it means to purchase a new car versus running one into the ground.
Yeah, I think I'm just aware of like how much, like I think about that quite a lot, but I know the majority of people don't always, and so it would rely on us having communicated that it's necessary, it's important enough for people to think about that, which I don't know that we have really done as climate scientists or whatever.
Just as a culture, it hasn't really been communicated.
Yeah, so
I mean, it has, like, right, there's Rachel Carson. I mean, when I was a kid, what was my dad reading? 8 Little Piggies. So, like, those things have been communicated. Like, they were on Discovery Channel when we were growing up, and Animal Planet. Like, they've existed. I think it's just culturally, only recently have I heard people talk about it in a way that it's not, like, brushed aside as, like, oh, that's some, like, hippie nonsense.
Yeah.
And I think... But culturally, there's still those decisions, in, like what I was saying about the cars, or like when I remind people, like, not only can you bring your own cup when you get coffee and not create more cup waste, but often you'll get a discount.
Yeah, right. So you bring some, put some selfishness back into it. Yeah,
right.
But yeah, I guess an answer that I think I've given before in conversations that I've had with people who don't do science,
with the common folk,
the commoners. No,
these uneducated people like myself.
But I think the basic thing is just not like try to be more selfless. Like consider your impact. Recognize that what you do impacts, has impacts that start from how you behave in your community, but then unseen connections to, what somebody in low-lying countries is going to experience through the sea level rise that we are driving as a country of people who emit more carbon per capita than most other countries. Right, we're up there at the top with China and Canada.
Which that data visualization, I don't know if you remember at how do you pronounce it? Vandenberg?
Yeah, Vandenberg.
Vandenberg. I can't remember if it's an N or an R in there. I'm like Vanderberg or Vandenberg. Anyways, when we were there, the NASA data visualizations literally show, what was it? I think it was carbon monoxide.
Yeah, I can't remember
emissions, some kind of emissions.
And you can see the global. If you ever need to illustrate something, go to NASA visualization. Right. It's out just.
It's amazing. That's a really good point, and I like that you brought up community, because I think a lot of the ways people think about things is like, how does it impact me? And if we all thought about these things in a proactive way and vocalize that. Yeah. In the same way that it's become socially acceptable to like get into debt to have a new car, it will then become socially acceptable to like be like, oh, actually I'm going to reuse this cup because it's like the environmentally thing to do without casting judgment on others, and just do that. And so I think what you said applies to like not only our communities in terms of like environmental impact, but also just in terms of like emotional impact and like showing kindness.
Yeah, I think there's a lot of big things going on in the U.S. right now, and like a way to, well, it's sort of caught right in the middle of it, I guess, is that concept of I'm not going to necessarily do the thing that purely serves me most. I'm going to do something that has a broader benefit.
Right.
That's a concept that to me is just fundamental, and I don't know exactly where it came from, but probably my mom telling me to be nice or something, right? But that is not a fundamental operating principle for a lot of people, apparently.
Which is...
I think we did know that, but it's certainly been made abundantly clear lately.
Yeah. I don't think that I really understood that I don't think I understood until I was like in my early teens. And I remember very specifically in church, like, because I grew up going to church, that I'd always had in my head I had to be a good example so that other people would also want to, like, go to, so that other people would want to, like, to also be positive and, like, go to heaven.
Yeah.
And then I remember, because I was like, oh, obviously it's very important that, like, everybody feels this way. Because that's, I was a kid, and if that's the only truth you're given, you're like, this is obviously the right thing. And I remember the kids that I was in church with were like, oh no, we're gonna go and, like, whatever it was, like, invite more people to come to church and, like, be a good person, basically, just so that we don't go to hell. And I was like, oh, I don't care if I do or not. I was just, well, you guys are all doing this out of fear and not because you care about other people. Like, and I was so defeated.
Strong motivator.
But I didn't realize that, like, translated to just, like, the general population outside of religion, of just, like, people are, like, voting for themselves because of their particular perceived situation and what the perceived outcome will be, which is shocking. So, on that note, I have one more question.
Yeah.
And it's a question I ask everybody. So, as I mentioned, the theme is, like, behind the scenes, across the board of, like, topics, verticals, types of careers, whatever. What is, like, one final product or kind of just behind the scenes of something that you would like to hear an interview on?
Whoa.
Oh, I should have sent this to you ahead of time. I'm so sorry.
Yeah, that's a big question. So some behind the scenes that I'd like to...
Do you want me to give you some examples of other people's?
Sure.
Okay, so somebody said, Karen Okonkwo of Tonal said, the behind the scenes of Oprah, just in general.
Okay.
What did my friend Jessica say? Oh my goodness. Hers was so good, and now I can't remember what it was. Somebody else, Matt said behind the scenes of, like, an executive, like a CEO. Mm-hmm. Some of my personal ones, and I'm speaking to somebody in this industry, actually. It's like the behind the scenes of recycling, and a few other things like that.
That's a big one.
Oh, Jessica said the behind the scenes, I think she said, of, like, a funeral home director.
Oh, gosh. Yeah, that can be...
Which I cannot wait to do that.
Yeah, my wife's grandpa was a funeral director. So
really?
Lots of interesting stories.
Oh, man.
I don't know. I don't feel like I have original answers. I mean, like, behind the scenes of things that matter. Like, behind the scenes of, like, the day in the life of a teacher or something like that. Like, those important parts of the community that you don't really hear that much.
Right.
Like, I feel like I also should know more about sort of behind the scenes of how the city operates or the county operates.
Right.
But that's where things really matter. And I'm still thinking, like, I wish I had better answers for what you can do to reduce your impact or steer us in the right direction for climate change and climate impacts. And a lot of it is just pay more attention to what your local community is doing and start spread the expectation that your local leaders are going to act on the quality information that they are provided by state agencies, by universities. Because if we don't start at the grassroots expecting that, it's silly to assume that we're going to get a top-down version of it,
right.
Which we do need. We need top-down from our federal institutions and our leading state institutions to say, hey, we've got this information. It's clear. A couple, 3-4 decades of rehashing climate change and this sort of process is enough. Like, we are damn confident in what we are facing. Yeah. And we're just stalling because of these barriers that have been put up very intentionally. Right. Yeah. It's always hard to know exactly what to do and what can you do, and like living in Washington, it doesn't feel like voting, or living in Seattle, it doesn't feel like I can vote for any difference than what we really have. Like, we're set pretty well as far as our options here, and having leaders that make pretty sensible decisions, but I don't know. Yeah.
So, local government functions.
Yeah, just be involved. That's a big downside of my career as well. Actually, just sort of thinking one last thing. Like, we travel, especially at the postdoctoral stage, sort of from 1 to 2 year positions. You're sort of not able to root into a place very well, and that really it reduces your impact in that community. And that's one of the things I've been craving. It's like I just want to be somewhere and know that I can stay there and really get into it.
Right.
So that's like what I guess the next big thing in life that I really want to do, not to like be boring and sound old or whatever, but like I've been moving around so much the last 6 or 7 years, I just am tired of not really knowing a place.
Peter Neff. Vote for Peter Neff.
Yeah, no, don't vote for me. There's a reason I study ice and I don't deal with people. I don't know.
You're too logical. Why put a logical person into office? That's crazy.
I do really like working and talking with people. So that's part of also, like, I get stuck in the lab so much, or I'm going to Antarctica for 3.5 months, and it's like you know, what you do is just not seen at that point.
Right.
So Twitter has become an interesting tool for me to feel more connected and feel like my work is doing something.
Awesome.
It's in the in-between stage of being an idea and being a publication or whatever other result we end up with, but pretty much publications.
That's super cool. Awesome. Well, thank you so much for being on. I really appreciate it. You are at Peter_Neff on Twitter, and then on Instagram.
I'm not much on
big on Instagram. That's
and
okay.
I'm a little bit embarrassed of my handle. It's
a great handle.
I see Pete. I get a lot of harassment from friends and family about that. But,
it's a hysterical.
It's a mix of ice and dog pictures.
It's great.
But yeah, I use Twitter a lot, and I enjoy the feedback and sharing things. And yeah.
Awesome. Well, thank you so much. This was really great. Thanks again for listening. I really appreciate it. I hope you found what Peter had to say interesting. I'll be sharing out some photos on my Instagram and Twitter from it. You can look it up if you're listening to this like later on, and obviously it's probably not at the top of my feed anymore. Just search #BTS podcast and you should be able to find it. The work that Peter does is really incredible, and I'm so grateful he showed me around the laboratory at University of Washington. Please subscribe, rate, and review this podcast. Share your ideas with me of what you want to hear on this podcast. Whatever, just share it with friends. Just the support is super appreciated. It is a little bit of a vacuum when you're making a podcast and when you even have one out in the open. On the previous podcast that I used to produce, we could see that people were listening, but the feedback loop was like dead silent unless I knew you personally. So it's just really good to know that people are not only listening, but have some sort of feedback. And if you're just listening to this to go to sleep, that's totally fine too. I'm flattered you think my voice is so nice. That's a huge compliment. But if you're not sleeping through this, please do subscribe, rate, and review. Share it with people. Let them know that you like it. It would be greatly appreciated.